All right, so today our objective is that you're going to know the definition of proportional. You can tell if a ratio is proportional. You can determine the constant of proportionality, and you can use the constant of proportionality to determine missing data. All right, so if you didn't already, these notes are on Schoology. You can go ahead and print them. All right, so two quantities are proportional if the ratio between the two quantities is equal. So it tells us Mario travels in 2.5 hours if he travels at the same rate. An equal same rate. How far can he travel in 5 hours? So what that tells me is the same means that it is equal. So if I can say that he travels 180 miles in 2.5, we're going to go ahead and we can say this is our warm up. I should have said that. So this is kind of what we did yesterday. We set up a proportion. We said, well, if I can go 180 in 2.5, so miles in 2.5 hours, and we're going to keep that order the same. We want to know if the hours is 5, how many miles can he go? So we'd go ahead, do our butterfly method, and say 180 times 5 is going to give us 900. And we're going to set that equal to our other diagonal. So 2.5 times x is just 2.5x. To solve for x, we divide both sides by 2.5. And so x, our unknown, tells us that he can travel 360 miles in 5 hours. So let's fill in our chart. It says, using the information about his rate, complete the table below. So we already were told 180 miles in 2.5. We just determined that he could go 360 in 5. So what I see is, because he's increasing at a constant rate, well, I add 2.5, I add 2.5, I add 2.5, and every time I add 2.5, I add 180, because every 2.5 hours he goes 180. So I increase 2.5 hours, I add 180. So 540. I increase 2.5 hours, I add another 180, because every 2.5 hours I'm going 180, because I'm hitting 180 miles every time. And it's not 180, it's plus 180. So we'd say that is 720. We go another 2.5 hours and add on 180 miles to our grand total that we've gone, and we're at 900. So the other thing I want you to notice and kind of think about is if I add the same amount, no, we'll just leave it at that. So we increase at a constant rate. So every time we added 2.5 hours, we said that each 2.5 hours we go 180. So we add 180, we add 180, we add 180, because every time that we go that 2.5 hours, we add 180. So using that logic and using what we learned yesterday, how many miles can he travel in 1 hour? Well, we did some of this yesterday with our unit rate. We said that if he can travel 180 in 2.5 hours, we want to know how many can he go in 1 hour. And we put miles an hour. And miles stayed on the top. Miles, hours. Set equal to each other because we moved at a constant rate, so they're proportional. Do our butterfly, 180 equals 2.5 times x. So 2.5x. Divide both sides by 2.5 to solve for x. And in 1 hour, he can go 72 miles. So, yesterday, we learned that that was called a unit rate. Well, today we're going to extend that. We're going to do a little bit more of the same thing because a unit rate is also called a constant of proportionality. But it can be easier to, once we find that unit rate, to make tables and figure out missing information. So this may be an easier way to solve for unit rate or that constant than we did yesterday. The value of the ratio of two proportional quantities is represented by y equals, k equals k equals y divided by x. And I don't like that they put this on the backs, but on the back real quick, where y equals your y value, k equals your constant, of proportionality, or our rate, and x represents our x value. All right, you got that? Cool. So now let's practice some of it. So they ask us, examine the table below. Describe the patterns that are true. So it tells us feet are x and inches are y. And we're going to plug in y over x, which we know gives us k. So we're going to put that there because they already told us. We know that's going to give us our constant and proportionality. And we're going to recognize the pattern. So what I realized is, so y over k, 12 over 1, 12 divided by 1 is 12. Okay, y over k, 24 over 2, 24 divided by 2 is also 12. Y over k, so 36 over 3, 36 divided by 3, also 12. Y over k, so 48 over 4, 48 divided by 4, also 12. 60 is y over k, which is 5. 60 divided by 5, also 12. So how do you know that the number of feet is proportional to the number of inches? We got a consistent 12. Every time we divided y by k, we got 12. The constant of proportionality, y over x, is always 12. Our k never changed. Constant, by definition, means it doesn't change. So because that constant proportionality, that y divided by 12, did not change, it is our constant of proportionality. If at any point that number changed, these would not be proportional and not be increasing at a constant rate. So using x, the number of feet, how do you find y, the number of inches? Well, how do I get from 1 to 12? Times 12. How do I get from 2 to 24? Times 12. Times 12. Times 12. Times 12. If I want to get from feet to inches, we're going to multiply by 12. So, to go from x to y, you would multiply by that constant of proportionality. Okay, or we already just said our constant of proportionality. All right, so our y we said was our y value, our k we said was our constant of proportionality, and our x we said was our x value. All right, so now we're going to apply our understanding of the concept of proportionality to answer these questions. It says, while training for a marathon, Keith's watch reported how many calories he burned at each marker. The data is shown below, and I'm going to say now that this is our x and this is our y. It says, is the number of calories proportional to the number of miles? Explain your thinking. Well, let's think about what happened here. From our x to our y, we multiplied by the same number. Let's try that. How do I get from 1 to 117 times 117? How do I get from 2 to 234 times 117? How do I get from 3 to 351 times 117? How do I get from 4 to 468 times 117? How do I get from 5 to 585 times 117? So that's true. What else did we do? What else did we see when we looked at this? Think about it. Y divided by x gave us the same thing. So let's try that. 17 divided by 1 is 117. If we go the other way, 234 divide by 2, again 117. So do you notice a pattern? To get from here to here, we multiply by 117. To go from here to here, we divide by 117. Is the number of calories proportional? Yes, because that's a constant that never changes. What was that constant number? Yes, because we already figured out each mile we burned 117 calories. We saw, and I'm running out of room, I would put that we saw each mile we burned an extra 170 calories at a consistent rate. We saw as we went up, we could multiply the miles by 117 to get our calories burned. We saw that if we divided those calories by that 117, we got the number of miles, and it changed at a consistent rate. So the next day, he ran 7.5 miles. How many calories did he burn? Well, we already saw that if we take our miles and multiply it by that constant, our rate, however many is 1, or that constant of proportionality, same thing. We multiply by 7.5, we're going to get the calories. So 117 times 7.5 is going to give me how many calories? 877.5 calories. Well, and it asks us what's the constant rate of proportionality? Our rate. For every mile, we burn 117 calories. Each mile we multiplied by 117. Each calorie we divided by 117 to get however many miles we walked. So write an equation to explain that relationship. Well, we did it. Calories burned divided. Calories. We did it. Calories equals the miles times 117, or calories burned divided by 117 equals our miles. And we already said that calories was Y and miles was X. So y equals x times 117, or y over 117 equals x. All right, so now we're going to use the information below to determine the constant proportionality in each situation. So our cups of oil is going to be our x. The cups of water is going to be our y. So 6 divided by 1.5, and this dash, not enough room to stand up on each other. 6 divided by 1.5 gives us 4. 16 divided by 4 gives us 4. 22 divided by 5 gives us 4. 30 divided by 7.5 gives us 4. Well, let's see. How do we get from cups of oil to cups of water? The opposite. Same thing. This constant of proportionality was our y divided by our x. And once we have it, we can multiply by that constant of proportionality to figure out our cups. So that 4 is our k. So I know x times 4, our k, equals y. And I know that y over x equals k. So if I had any of my missing information, I could plug them in and figure out what we're missing. All right, so same thing. Our hours are x. Our miles walked are our y. I want you, and here, x, y. We've done a couple of these. I want you to pause this, and I want you to solve these two. Fill in the table, figure out what our constant proportionality is. How do we get from hours to miles? Do the opposite. So what do I multiply to get from here to here? And if I divide, do the opposite to get it. So go this way is multiply. This way is divide. Did anyone get that? We're going to get that constant. Fill in your table. Figure out what that constant or proportionality is, that rate. For these two. I already gave you what x and y are. All right. So y divided by x, should have said 3 divided by 2. Did you get 1.5? 6 divided by 4, 1.5. 9 divided by 6, 1.5. 12 divided by 8, 1.5. Every time it moved, it was that 1.5. We know y over x is going to give us 1.5, but just for funsies, what if I went this way? Sorry, we just went that way. What if I went the other way? Now that I have that 1.5, 2 times 1.5 gives me 3. 4 times 1.5 gives me 6. 6 times 1.5 gives me 9. 8 times 1.5 gives me 12. Because that is true, we know we found the right constant of proportionality. All right. So, to find the rate, all we have to do is pick the 1. As they tell us that this is proportional, and you need to find a rate. We don't have to set up an equation like we did yesterday. We can say y over x, 36 over 3. But here, we're testing to make sure they are. 60 divided by 5, 72 divided by 6, and 96 divided by 8. And every time, we get 12. Let's decide if that's true. Times 12, yep. Times 12, yep. times 12. Yes. We did it right. That constant is times 12. Both of those. All right. So, summarize today's lesson. Well, today we learned that rate we were talking about was can also be known as a constant of proportionality. That's what we're increasing by. We learned that we don't have to set up a whole proportion. We can use some of that determining how they change, and we can divide our y by our x to find that constant. And once we have that constant, we can go back and multiply it to check to see we did it right and that it's the same each time. We learned that if those ratios are the same, which in this case they were, those quantities are proportional. So all these tables we've made show proportional. That means as x increases, it increases at that constant rate of proportionality. So for every x whatever, the y changes by the constant rate of proportionality. So in this last one we did, where we had feet and inches for every 3 feet, there are 36 inches. That constant rate of proportionality is 12. So what that tells me is that for every 1 foot, there is 12 inches. That constant rate would be your answer for 1. So same for here. Because we got a constant rate of proportionality of 1.5, for every 1 hour, it would be 1.5. And the same up here, we had 1.5. So we know that for every 1, it would increase by 4. All right. So I kind of walked you through your summary, but make sure with your notes you include a summary where you talked about what we learned with that constant proportionality, how to find it, what it is. Make sure you answer our objective in your summary. All right. If you're still struggling, please come to our guided practice. If you're not, you can go ahead and get started on your Schoology assignment. Otherwise, I will see you guys in class. Have a great day.